kind of a three-part question there.
Right. I hope I'm audible, right? Okay.
Sorry.
To answer that.
Okay.
Yes. Sorry. Just to answer that, yes, Fischer-Tropsch technology, specifically Fischer-Tropsch unit cracking, is flexible enough to produce staph, to produce diesel. The catalytic conditions can be very well tuned to such kind of productions with a very little hardware change at the back end. Means you should have ability to draw diesel. The common byproducts are naphtha or off gases. The thing is that if naphtha is not that, it does not have that high octane, right? It is basically those paraffinic contents are pretty high. But this naphtha is definitely good for like petrochemical naphtha, specifically to the light olefins. So as customers or developers, if you are having an offtake for this naphtha, definitely that is one pathway. But typically, what we have been seeing to recycle this naphtha or off gases back to the upstream units, like the autothermal reformer and all, and you can convert it into more syngas, then FT crude, and eventually to SAF or diesel, whichever is your production targets.
Okay. Another question here. What is the minimum capacity to justify economy of scale? And as kind of a part two, what is Honeywell UOP's experience and ability to design such units at different capacities?
Thanks for the question. And I think in one of the slides, I have shown that we have experience for like 1 barrel per stream day to right now the one that we are working with DG Fuel, which is for now the highest capacity, almost like 30,000 barrels per stream day of SAF. So we have seen all sort of varied capacities. The most common number we have seen is like 100 kilotons per annum of SAF production. That is a pretty common target that we have been seeing. So from economy of scale perspective, there are two things. Typically, if you're looking for commercial scale, and of course, depending upon the regions, your price points, availability of hydrogen, at what price your hydrogen or the green electricity is available, definitely those things have a play on the economics. But typically, I would say anything more than 50 to 70 kilotons per annum typically justified the economics. Having said that, we have seen, the customers, they sometimes go for a demo plant level capacities where they would like to see as a more of a proof of concept because we are at quite a beginning phase of this technology implementation. So we have seen also, like I said, as low as 1 barrel per stream day. In fact, one of the number that I have shown on my slide was we have this experience to design for a 13 barrel per stream day for a demo plant. Which ran successfully for 5 years. So yes, there are many different such capacities are available.
Okay, got another question here from our audience. It's kind of along the lines of economics of the FT unit cracking. FT reactors are tubular reactors, and they are very expensive. What has UOP done differently to design within the design to reduce the cost of FT reactors?
Yeah, thanks for the question. And the way I would answer, first come to the FT upgrading of the FT unit cracking side of it. Now, the good part is that if you are aware about the hydroprocessing or hydrocracking technology, I think the FT crude being paraffinic is one of the easiest in terms of the the hydrocracking the chemistry to crack those molecules back to the desired range of products. So typically these kind of hydrocrackers or FT hydrocrackers are pretty low pressure. it is almost like if in a traditional refinery, if you have to compare, it is almost in the range of your like the diesel hydrotreaters and all that you have seen. It is almost similar to that pressures. And apart from that, technology-wise, what UP has chosen multiple things, like we have the single-stage recycle flow scheme concepts, and we have more than more than 80 plus units running successfully globally. Over and above that, I think one of the questions I was probably the thing is very common questions. The catalysts that we have been using. So in a Fischer-Tropsch technology, the catalysts can be both base metals or the noble metals. Typically, we go with noble metals. So what happens with the noble metals? Yes, there is a high cost of catalyst initially, but where it pays off is this noble metal catalysts. They don't need those additional, the reduction of the sulfiding states, so which means there are a lot less, the byproduct stream creations or the waste streams productions from this unit, which means some of those associated the units, those auxiliary units that you typically see with the base metal catalysts, those units and those capex you don't need to invest. So overall, when you say it's just not about the Fischer-Tropsch operating reactor, I would say it is about the overall technology, and there are multiple of such technology innovations that are happening to bring down the overall the capex of this kind of technology or this kind of project.
Okay, another question from our audience. What is the TRL for FT unit cracking?
So yes, so the technology readiness level for specific to, if I talk about in partly, so Fischer-Tropsch upgrading of the Fischer-Tropsch hydrocracking is just your hydrocracking technology. So it is definitely, UP has more than 250 plus hydrocracker running globally, probably another 370 plus hydrotreaters, like more than 600 plus hydroprocessing units successfully operating globally. So from a TRL point of view, this unit cracking of these Fischer-Tropsch upgrading units are at a highest level. That's what I would say. It at the TRL level 9. So there are different terminologies. Now come to the upstream Fischer-Tropsch technology. Also, in many ways, these Fischer-Tropsch technologies are also, the commercially, there are operable units. There are demo plants. So based on that, I would say the overall the technology readiness level of the Fischer-Tropsch pathway is pretty much at its highest level. Definitely, there are all sort of different feedstocks that also evolving, and we are looking into that. And definitely, in such cases, we are working with our customers, with the developers to understand it more. But by far, so far, whatever we have seen, the technology level, it's pretty much at its highest level.
Okay, here's a question about Fischer-Tropsch versus methanol to jet. Kind of another two-part question here. What is the most efficient way to produce E-jet, and what is the cheapest one?
Thanks for the question, and I think this is one of the very common questions we listen from our customers. And see, as Honeywell UP, like I said, we are pathway agnostics. We would love to talk to you about all the technology possible ways, and there is no straightforward answer to it. The reason being that, like I said, every region is based on its feed and product pricings. What is the type of feed available? What is the price of your green electricity? What is the type of, the availability of hydrogen? So there are multiple of such factors, variable factors, which influences, the one pathway over the other. There is also the customers who does not want to just rely on one particular pathway because of, the overall reliability and the security of the energy security. They would like to have both pathways. So as Honeywell UP, the way we work with our customers for both pathways, we give them sufficient information. So, and then collaboratively, we develop a case that which one makes sense for, which customer or where it makes sense for them. And each of these pathways has their certain, I think that, the technology nuances. For example, methanol as itself as a product, it has its own value in the market. So there are customers, if you're looking for like a more staged investment, yeah, that can be a one possibility of that. At the same time, the Fisher-Tropsch pathways, like I mentioned, it has a very high technology readiness level because the back-end Fisher-Tropsch upgrading also is kind of a proven technology. Also, it's an ASTM approved pathway since 2008 or 2009. So multiple of these factors play a role for a customer to choose not just probably the economics or the cash cost of productions. And when we are looking at over a span of next decade or next 15, 20 years, many of these factors become quite prevalent for our customers, and we work with them so that they take a more informed decision.
Okay. Here's another question that part of the answer, I'm sure, will be various factors determine this, but the question is how much hydrogen is required for the FT unit cracking process? And second part is, can that hydrogen be produced from naphtha or off gases?
Yeah, so I probably see this is and I'll be very honest and candid. Of course, for your specific case, because the Fisher-Tropsch, once the syngas is produced, is processed through the Fisher-Tropsch technology. The Fisher-Tropsch liquid, as such, its composition we have not seen it so much. It does not vary that much, right? So yes, hydrogen-wise, we exactly know where we are. Probably, if you have a specific questions on hydrogens, we can talk offline and can have a NDA in place to discuss about that specific numbers. But yes, there are multiple ways also, the hydrogen can be produced within the technology, within the overall technology portfolio itself. Like, for example, water gas shift, those kind of reactions are possible. Like you mentioned, naphtha and all of that by circulating and all. In fact, hydrogen that you lose to the off gases, you can recover such hydrogen. So yes, there are multiple means available to bring, some of those hydrogen elements. But one thing you should know, the majority of the hydrogen probably will be consumed upstream, probably not in the Fisher-Tropsch upgrading. So if you are looking for an hydrogen, availability is definitely one of the pieces that either whether you go for the methanol pathway or the Fisher-Tropsch pathway, the availability of the hydrogen and how do you want to produce that hydrogen means whether you have access to the local grid, whether that can give you a certification for the SAF as a SAF or eSAF, or you have an availability of green electricity and what phases you want to implement that project. So a lot of these factors will need to be discussed in totality to see and bring the hydrogen element to the overall technology pathway.
Okay, another question from our audience. Do you use noble metal cracking catalyst in your FT unit cracking process?
Yes, so like I explained, so both base metal and noble metal catalysis, both are possible. Both of them have their own pros and cons. Of course, noble metal catalyst will be more selective towards specific middle distillate range production. So yes, UP has both of these catalysts, and typically in most of the cases that offering that we do nowadays, it goes with the noble metal catalyst.
Okay, and kind of a follow-up question from another audience members. What is the design life of the FT unit cracking catalyst, and how many times can it be regenerated?
Okay. So see, Fisher-Tropsch upgrading as such, it's a very, the upgrading technology-wise, it's very clean environment because as such, Fisher-Tropsch liquid or this FT crude that you see, it does not have the typical, the sulfur, nitrogen, all these contaminants because those things you have already eliminated from your syngas before you enter into the Fisher-Tropsch technology, right? So this is a pretty clean environment. You can design live in sync with the upstream, the Fisher-Tropsch, the technology provider, so which means it can be designed for 2 years, 3 years, 4 years, 5 years. It is just a matter of how you want to bring a sync to the upstream unit. When it comes to the base metal specifically, as you know, typically the base metal versus precious metal. For specific to precious metal, we don't recommend regeneration. It's typically go for a metal reclamation after a certain period of time. So that's how it goes, right? If you go for like a base metal and all, definitely regenerations and things are possible. I think these things are evolving, like I said, for specific to the Fischer-Tropsch upgrading and all. We have an experience of Fischer-Tropsch upgrading to more like a diesel productions, like I said, as a demo plant, which ran successfully for 5 years, and that ran for 5 continuous years, right? So we have all sort of these experiences, which pretty much tells us that, you know, these technology or the catalysis can pretty much give you a stable life as much as you want in sync with the upstream unit, but the typical numbers are anywhere between 2 to 4 years.
Okay, and then let's circle back again here when we were talking about how much hydrogen is required for the process and can that hydrogen be produced from naphtha and off gases? Another question kind of came in and they're asking, can you use green hydrogen and what is the effect or the increase in production of SAF or sustainable aviation fuel?
Yeah, so typically, see, any chemical reaction specifically to this kind of an hydrogenations, whatever your the chemical consumptions of hydrogen that you need is meet. Of course, depending on what type of makeup gas or the overall the impurities that you bring with the makeup gas, of course, that needs to be looked at. Right, and it is more to do with what kind of the product range material that is available in your Fischer-Tropsch liquid, and then definitely what kind of catalysis and your proprietary technologies that we have been using to overall increase the the middle distillate range product. So not hydrogen per se as a source of a hydrogen, but overall technology selections, the catalysis, the compositions of the Fischer-Tropsch liquid, and different contaminants levels that are present in these kind of a makeup gas or hydrogen, that all has a certain impact on the overall productions of the SAF or the renewable diesel product.
Okay, another question here from our audience. What is the technology readiness level of the FP technology?
Yeah, I think I answered it. I think probably at the beginning, like I said, Fischer-Tropsch upgrading technology, UP has more than 600 or 650 plus hydroprocessing units running globally. It is just, kind of another version of the hydroprocessing technology, and being in the hydrocracking technology, the paraffinic hydrocracking, I would say, is one of the easiest part of the hydrocracking. So yes, it is at its highest technology level. Also from an upstream Fischer-Tropsch technology perspective, also the different elements are kind of proven or operating on a different circumstances or purpose. So yes, the overall technology as a Fischer-Tropsch pathway is almost at its highest level. So that's what I would say.
Okay, and then just kind of a general question. What kind of support is Honeywell UOP providing to help customers or developers to develop their SAF projects?
Yeah, I think it's a great question. So there are many different parts of it. The first part is, like I was explaining, a little bit of my project development. Definitely when we hear from our customers, then typically we would first like to execute an NTA with you, and once we have that NTA in place, we would like to understand your project, the various aspects of it, where you are about these projects, what is your SAF production target, and definitely according to your requirement, we kind of develop the technology around you. We typically go with the first phase, which is pretty much preliminary data, just to support your understanding so that you can understand the overall economics. And then once you are ready, then you go drill down to that further into the multiple phases. Like you then go for a very detailed study to get to the more, the class from class 5 to class 4 level of cost estimates. Then class 4 to you, once you're ready, you go to a basic engineering phase where you further narrow it down to the level where you think now this is the time when you can actually go and understand and probably go for a FID. But at the same time, there are customers who are looking for also the funding or the LPOs and all. Of course, we also work with our customer for such funding applications. Definitely, as Honeywell, we can provide you, all the supporting documents and whatever other administrative support that you need from us, which should tell you that typically all these technologies, when you go for a funding application, it tells when Honeywell or UP is standing behind you, which means you have a good backup. As an overall technology, the licensing of the technology, I would say the readiness or the reliability point of view. And definitely, there are different countries and customers where definitely you need a more discussions and not just with the customers or between the licensors. There are other different parties are also available, like the project developers. Sometimes you are looking for the upstream licensors. We can bring and give you the contacts of those upstream licensors. So it's an holistic approach. Once you are with us, we work with you to develop the whole project. It's not just about a Fisher-Tropsch upgrading. It is about this entire complex of the entire technology portfolio we work with you.
Okay. I think we have time for maybe one more question from our audience. Let me throw this in there. When is the ethanol to jet technology chosen instead of FT?
Honestly, in the customers, if they are looking for ethanol to jet technologies, like I mentioned, specifically to the locations like Brazil and US, where it is more favorable. If you know, when it comes for ethanol to jet technology, definitely from a cash cost of production perspective, 1G ethanol, first generation ethanol to jet is pretty much competitive or at the lower cash cost of productions. But then there are countries where we have seen, it's more like those food versus fuel debates. So there, the moment you go for a 2G ethanol, these additional processing costs essentially, takes the cash cost of production much higher than typically the Fisher-Tropsch pathways and all. So it is very much country specific, I would say, than just the technology pathways or the direct comparisons between the technology pathway. And as Honeywell, like I said, we are pathway agnostics. We have technologies available for all these different pathways, and definitely, like, we work with you to understand your projects, your regions, your numbers, the way you are evaluating your projects, so that we can help you out in all those aspects.
That's great, Surendra. We appreciate you sharing your expertise with us. Any final closing comments?
No, so on the closing comments are, yes, these technology portfolios and these kind of a technology, I think it is just not with one customer or one licensor or with one developer, because these are the mandates and considering the social, economic, and all these, the overall, the global targets to meet these SAF productions. And this is real. We are pretty much into these energy transitions. And when you are thinking about these projects, of course, you are thinking about the economics, the cash cost of productions, but at the same time, you need to understand that, this is real. This change is going to happen eventually. So I think you need to start looking from that perspective, that the early entrant in the market, the people who are thinking more into these kind of a projects, how to develop around that, we can help you. And there are many different ways we can make this, your case, a reality. And it is not just about building a complete brand new project. It is possible that you have existing assets. We can look into that. Existing assets, that how we can utilize that to minimize, those the capex, your investment point of view. So there are multiple of such elements we can bring in as an overall technology portfolio or as a licensor to you. But the thing is that thinking and that thinking process has to start now, because that's what is going to happen. And I'll be happy to talk to you. I think my email address, my IDs and everything will be available to you, post presentations and all. Please reach out to me. You can reach out to me through LinkedIn, through my Honeywell official email ID, and definitely we'll come back to you. We'll talk to each one of you to make your case a reality. So that's my parting comments. That's what I would say, Mike.
That's great. We want to extend a special thank you to Devendra Chakraborty for sharing his expertise and answering those questions today. And thank you to Honeywell UOP for putting together this timely and informative presentation. Thank you to our audience for attending. Finally, an on-demand version of this webcast will be made available in the coming days and will be emailed to everyone. So again, thank you to Surendra, and thank you to our audience. We hope you have a great day.
Thank you.